Good evening. I am Professor Shalini Sahay, Assistant Professor from EC Department, Sirt Bhopal. Today, in this lecture, we are introducing the basic concepts of the telecommunication. Introduction to telecommunication. First, what are the objectives of telecommunication? To provide a broad overview of communication systems, to describe the main components of a communication system, to introduce the concepts of a signal, and to classify different types of communication systems, to introduce the concepts of modulation in communications, to introduce the effect of noise in the system performance, and to describe the key factors to evaluate the performance of a communication system. Now, what does telecommunication means? The telecommunication consists of tele and communications. So, what we say tele means over a distance, and in the communication, it is the process of exchanging information. Thus, telecommunication means exchanging information over a distance. So what are some communication system we used every day? For example, some of the typical communication systems are like copper wire communications, where we use the cables for transferring the information from the transmitter to the receiver side. Examples are telephone, modem, DSL, broadbands. Now, wireless communication. So where the mode of transmission media is the wireless, means it is the atmosphere. Cellular communication, radio, TV broadcast, satellite communication, and the fiber optic communication, where we use for the global long haul communication. The importance of communication system in modern lives. So applications where there is a start from, so they are developed right from 1994, and the main technologies which have also developed along decades. Now we can say that we can buy the things online, we can do the transaction online. So here we require the communication, and it is mainly used in our daily life. Now the components. What are the basic block components of a communication system? First, the person who talks on a phone, that is the message source. Microphones. Sound is converted into electrical signals. Sender antenna to the base station to a receiver antenna, that is the transmission channel. Speaker. Electrical signal is converted back into sound. So person who listens is the message destination. So a person who wants to transfer his information is the source, the medium through which he wants to transfer the information. For example, microphone, antenna, or speaker, or any other mode of communication he can use, and to whom he wants to transfer the information will become the destination point. Now the cable TV broadcast system, here the image or the action is to be filmed, or the message source. Video camera, here the images are converted in the form of electrical signals. Underground cables, these are the mode of transmission channels. Now the television at home, where the electrical signal is received and it is converted back into the image, and the person who wants to watches the television is the destination. So here the source started, and these are the mode or the medium of the transfer of the signal or the information, and where it has to be reached is the message destination. So in the form of block diagram, we have drawn the block diagram of a communication system. This is the source. Here the information which has to be transferred, it can be in the form of human voice, TV picture, or data. Transducer, which will convert the physical quantity into an electrical signal. Now the transmitter, through which the signal is modulated and it will be transferred to the channel, where the noise or the distortion is also introduced, and after bypassing through the channel, it will be received by the receiver. Then again, the output signal will be converted in the form of message, and it will transfer to the destination point. So this is the transducer where the physical quantity is converted in the form of electrical signal, and it is the inverse transducer where the electrical quantity is converted in the form of video or image. So these are the examples of the block diagram which we have discussed. Now the classification of communication systems. Depending on the transmission media channel used, that is known as the line communication system. In line communication, transmission is carried out on the transmission line. For example, wire, coaxial cables, optical fibers, these are the examples of the line communication where the media is through the wire, and wireless where the signals from various sources are transmitted through a common media, that is the space. For example, radio, microwave, etc. Now the communication system can be simplex or duplex. Duplex means the information can be transferred in both the direction, means from the transmitter to receiver and from the receiver to the transmitter. Simplex, it is a form of one-way communication where the mode of transferring the data in only one direction. So these are the examples. Now the signals in communication system. So a message must be converted into signal before it can be transmitted in the transmission channel. So first, the basic block is to convert the physical quantity into an electrical quantity. Then only the signal processing can be done on the signals, and it will be transferred for the further information. Now, in a communication system, the function of transmitter is to modify the message signal for efficient transmission to the channel, that is to perform the modulation. So if we have to transfer the signal for a longer distance, so we can't transfer the signal in its original form. We have to convert, or we have to transmit on one carrier signal, which is a high frequency signal, and the process which we adopt is known as the modulation. So what is a carrier wave? So in communication, a carrier wave is a sinusoidal wave of high frequency. So for example, it can be a cos wave or sine wave. It is amplitude, it is the carrier frequency, and this is the phase. So modulation, what we can define, it is a process of impressing information onto the carrier for transmission by varying a parameter of the carrier in proportion to a signal. So these parameter can be amplitude, phase, or the frequency. If we take the signal, the amplitude of the signal changes according to the amplitude of the carrier signal, so it will be termed to be as amplitude modulation. So MT is the message and cos omega CT is the carrier signal. Now first, when we transfer the signal, and in the communication, the main importance of the signal is its frequency. So when we talk about the frequency, then we will discuss the bandwidth. So bandwidth is the portion of the electromagnetic spectrum occupied by a signal. So here we can define a bandwidth. So range of frequency, highest frequency minus the lowest frequency, and which will show the bandwidth of the signal. Now, if a signal has too large of a bandwidth for the channel, so it will undergo distortion and affect the system performance. Why is modulation is necessary? For various several reasons, modulation is very much required. Now the efficient transmission. By the use of modulation, message can be transmitted at a desired frequency band. For example, in a radio wave transmission, for efficient radiation of electromagnetic energy, the physical dimension of the radiating antenna should be at least greater than or equals to 0.1 lambda. So lambda is the wavelength, f is the frequency, and c is the velocity. Now, why modulation is necessary? Frequency allocation and efficient spectrum utilization. So, modulation can shift the frequency spectrum of the signal to the location centered on the carrier frequency. So, in the form of modulation, we can transform the frequency from the low frequency band to high frequency band. Now, the modulation moves signal spectrum to its assigned frequency range without overlapping. So, thus realizing frequency division multiplexing. So, in FDM, we will divide the frequencies to different users to share the same message. Now, this is the frequency spectrum allocation for high frequency radios, and it is the broadcast frequency band list. Now, noise in communication system. What is a noise? Noise is an undesired signal which carries no information. So it is an random and unpredictable, means its nature cannot be predicted. So a noise which is caused in sometimes in the loudspeaker or any other mode of communication, where it mingles with the message. So it can be disturbance which will disturb our original signal. So it is also a signal, but it is an unwanted signal, and we cannot define its position when it will come or it will not come. So we can say that it is a random signal. If the noise level becomes high, so the information cannot be recovered. Even for lower noise levels, the quality of the information reception will be reduced. So if we reduce the sound, so the noise will reduce, but the quality will also be reduced. If we increase the noise level, increase the sound, then the noise level become also high. So it will corrupt our message signal. So in a communication system, there are two main type of noises, external and internal. So the electrical noise that is introduced in the transmitting media is treated as external noise, and the noise introduced by the components in the transmitter and receiver is known as internal noise. Now, again, we can define external noise into two kinds, man-made noise and atmospheric noise. So man-made noise, what we say is that the noise which is introduced by the man-made apparatus, for example, the electromagnetic waves generated by the things like electric motors, power lines, etc. So these are the noises which is caused due to the machines or the apparatus which we used for the communication system. Now comes the atmospheric noise. This is the noise which is caused due to the disturbances in the earth atmosphere. Now, noise in the communication systems, internal noise that is produced by the electronic circuits, and there are mainly two types of internal noise, thermal noise and short noise. Thermal means the temperature. So the temperature which is generated due to the resistive component, rapid and random motion of electrons and atom inside the components, which increase the temperature and thus causes the noise. Now this motion increases with the temperature, hence thermal. And this random motion of electrons produce an unpredictable components, hence it is called noise. Sometimes it is also caused as Johnson noise. Short noise, which is in all active devices, especially in transistors. Now it is the noise which is caused due to the random variations in the arrival rate of electrons or holes at the output of the device. Now these noise are additive in nature, which means that they are add with the signal. So this is the main factor that limits the communication system performance. So it is to be measured, and but how it is can be measured? So we will measure with the help of the signal to noise ratio. So it is in comparison of noise and the signal power at the same point. So it will be defined as signal power upon the noise power. So this ratio is defined as signal to noise ratio. So if this factor should become high. When it will become high? When the noise will be low. So signal to noise ratio is defined in terms of power, signal power upon noise power in the form decibel. So we'll take the natural log 10 log 10 PS upon PN. Now limits. Noise of imposes a limit on the rate of information, so which is unavoidable. So why it is unavoidable? Because in the temperature above the absolute zero, thermal energy causes microscopic particles to exit random motion. So the random motion of charged particles such as electron generate random currents and voltage. So at particular temperature, the electronic devices which are temperature sensitive devices, so at particular temperature the noise becomes unavoidable. So it exists in every communication system. And due to various reasons, every communication system supports transmission at certain limited frequency bands only. Bandwidth and noise limits the communication system performance. Now, how to evaluate the performance of a communication system? With the help of efficiency. Efficiency means to determine the capacity of transmission channel per given bandwidth. Reliability, to determine the signal quality. Now, in analog communication system, efficiency is measured by transmission channel bandwidth and reliability is measured by the system output, that is the signal to noise ratio. So with the help of this, we'll define the signal to noise ratio. Now the communication system performance. In a digital communication system, efficiency is measured by a bit rate. है ना? So it is reliability which is measured by the bit rate. These are the components of a communication system. Now in phone system, source is speaker, cable broadcast, TV stations, transducer, microphone. Here the transducer is video camera. Here the channels is wireless. Here the copper wire or the fiber. Transducer the speaker. Here the TV, and destination is the listener, and in TV are the viewers. So this is the telecommunication line communication system. This is the signal which is transmitted through the telephone. It is transmitted, transmission line and the receiver. Now the wireless communication through wireless means without wire, and transmission is through the space. So this is the TV transmitter, and this is the antenna. Through the signal is transferred to the satellite, and through satellite it is coming to a antenna, and we are reaching the signal. So modulation can be performed by multiplying the message signal by the carrier wave signal. So this is the modulation. After the modulation, high frequency carrier signal which has been modified to carry the lower frequency message signal. So this is the main spectrum utilization, how the channel bandwidth may be much larger than the signal bandwidth. Modulation moves signal spectrum to its assigned frequency range. So it is known as frequency division multiplexing. Telecommunication, when a signal changes rapidly with time, its frequency is high and spectrum extend over a wide range, and the signal has a large bandwidth. So that is the bandwidth is known as the transmission bandwidth. So a large signal bandwidth, a large transmission system bandwidth. Thermal noise, it is a frequency content is spread uniformly throughout the usable spectrum. Thank you.